diversity technique is one of the important techniques of handling multipath effect or fading in your wireless propagation channel. In this lecture, we are going to discuss the fundamentals of the diversity. What is diversity? Why is it needed? How it is used to handle the fading problem, and why diversity is effective for handling fading in your wireless propagation channel or multipath effect. What are the different types of diversity which is there in your syllabus as part of your advanced communication system? Okay. After this, we will cover the different types of diversity techniques which are there in your syllabus, and the most advanced topic that is there for handling that is there for diversity is the element scheme. And after this, you have other three techniques, advanced techniques. But if time permits, only then we will go through these topics. Otherwise, we will finish a lecture at the sixth unit, that is your element scheme. So, for wireless communication channel, the most important effect of wireless propagation channel is from the transmit to the receive. When the signal is propagating through the channel, it experiences multipath effect. Now, multipath effect is because of reflection, diffraction. It is because of scattering, it is because of refraction, all those kinds of effects. So there are different things that are experienced due to this effects. First is called the path loss. Path loss is nothing but the loss the signal experiences when this is propagating through the wireless communication channel, and as the distance between the transmitter and receiver is increasing, the received signal power is reducing. So if received signal power is reducing, then what is happening? The amount of loss to the communication channel is also increasing. So what is this path loss? This path loss is nothing but the ratio of the transmitted signal power by the received signal power. So as the distance is increasing, the received signal power is reducing. As the received signal power is reducing, the path loss is increasing. Okay, so this is what is one of the signal impairments. Okay, that means loss. Second loss, which is there in your syllabus, is called shadowing. Now, what is the effect of shadowing? Shadowing means you have a transmitter and you have a receiver. So, between this transmitter and receiver, suppose you have a very large obstacle. Okay, so what is happening? Here, transmitter cannot see the receiver because the receiver is hidden behind the obstacle. So size of the object is very, very large. That means it can be a big building, any obstacle which is there. Okay. So what happens is when the signal is passing through this wireless propagation channel, because the receiver is hidden behind the big obstacle, this signal will experience multiple reflections and will reach the receiver which is behind the obstacle. So when it is experiencing multipath effect or multiple reflections, what is happening? The amplitude of the signal is reducing and the phase of the signal is also changing. So both the amplitude and the phase of the signal is varying. So if the amplitude and phase of the signal is varying, so if I'm transmitting one signal, the received signal will be entirely different compared to the transmit signal. So this difference between the received signal and the transmit signal is called the fading effect, or it is also called distortion in your wireless propagation channel. So when the receiver is behind a large obstacle, that is called shadowing. And what is fading? Fading is the most important concept or one of the most important impairments of your wireless propagation channel. So in this fading effect, what is happening? When you are transmitting one signal, multiple copies of the same signal will receive at the receiver side. So if you add all these components at the receiver side, what is happening? You will find that in some cases, the phase of the signals components, multipath component, would be exactly equal to pi or 180 degree. So when this is exactly equal to pi or 180 degree, what is happening? That the signals will cancel each other. So if you add the signals, you will find that they cancel each other. So they cancel each other means there would be destructive interference. Destructive interference means what? That the signal power at the received side, so power received is almost equal to 0. Almost equals to 0 means it appears as if there is no transmission from the transmit signal, which is not the case. I am transmitting a signal, but at the receiver side receiving 0 signal. So the transmit signal is being lost because of this wireless propagation channel due to multipath effect. So this variation in the channel in the signal amplitude with respect to time rapid change is called the fading effect. Okay. Now, apart from these three effects, you also have something which is called noise. Noise is any kind of unwanted signal which is present in the your transmitted signal, or it is introduced in the wireless communication channel. Apart from this, you also have thermal noise, which is introduced due to the environmental factors. All different types of noise are categorized or modeled as your additive white Gaussian noise. Okay. Now, amongst all those effects, the most important effect is that hampers the signal. It hampers the signal's integrity. It causes distortion in the received signal is called fading. Why? Because due to this destructive interference or fading effect, the signal power can become so weak that we can have scenarios where the signal strength reduces to almost zero. That means no signal can be received at the receiver side. So due to this fluctuation in the amplitude and the phase of the signal, such that the ultimate cumulative effect or the summation effect of the components results in destructive interference, fading is much more drastic compared to path loss and shadowing or noise effect. Okay. Now, the basic concept of diversity, why or what is diversity and how diversity will help to overcome this fading. So, our major objective is to overcome the effect of fading using diversity. How we are going to overcome this using diversity techniques that we need to understand. So, in normal scenario, what is happening? We have a transmitter and we have a receiver and we have a communication channel. Okay. So one signal is being transmitted, that same signal is going through this communication channel and is being received at the receiver side. So what is happening? One signal is being transmitted, one signal is received here. But in case of diversity, what is the need? The need is to transmit or receive multiple independent copies of the same signal. So this is very, very important concept here, that we want to design a system where the transmitter and the receiver will be exchanging multiple independent means there would be no relation between one signal to the other signal. So in multipath effect, what is happening? When the transmitter is transmitting one signal, multiple copies of the same signal is being transmitted through the wireless propagation channel. So the first factor is multiple is catered in your wireless propagation channel. So I'm transmitting one signal. Suppose the signal's frequency is S. I'm transmitting one signal, but due to this multipath effect, multiple copies of the same signal is being propagated through the wireless communication channel. Okay. So the first category of diversity is met here. Next, it should be independent copies. Independent means what? Independent means, suppose this is my multipath component 1 and this one is multipath component 2. So independent means there should be no relationship between the two components 1 and 2. No relationship means that they should not be equal or equivalent, or they should not match each other. Okay, we will study what do you mean by independent or unrelated relation. We study this in the next slides, but basic concept is these two should be independent of each other. Independent means there should not be any dependency, there should not be any relationship, there should not be any similarity between multipath component 1 and multipath component 2. Okay, so all this should be generated from the same signal. That means transmit signal should be same. So this is also one of the important factors here. Same signal is being generated from the transmit signal, but due to this multipath effect, multiple copies of the same signal is created in the communication channel. That means your wireless propagation channel, and each of these components are independent to each other. That means there is no dependency between each of the components. Okay, so this is the ideal scenario where diversity can be implemented. So this is the requirement of implementing diversity. So diversity means I need a transmit and the receive system where I will have multiple independent copies of the same signal being propagated from the transmit to the receive section. So this is a receive, so this should be RX. Okay. Fine. So for diversity schemes or diversity technique, we need two or more input signal from the transmitter to the receiver, that is multipath components. Okay. And each of the input should be unrelated or uncorrelated. Yeah. Only then we can handle the effect fading in the wireless propagation channel. Yeah. So if one copy is experiencing deep fading, one copy means suppose multipath component 1 is experiencing deep fading. What is deep fading? Deep fading means strong intersymbol interference. So if one of the signal is experiencing strong fading or strong symbol interference, then the other copy, that means the second signal, may be a strong signal or it may have some strength of the signal, such that why we need multiple copies. If one signal is being lost or signal strength is reducing due to the propagation channel, the second signal should be strong enough to be received at the receiver. So what is the goal here? The goal here is that the signal should not be lost. That means if I'm transmitting one signal, if multiple copies are being propagated, even if one copy is lost, that means suppose multipath component 1 is lost because of this effects, reflection, refraction, diffraction, scattering. But still, the second copy can be propagated and it will be received at the receiver side. So that means that the communication channel is maintained. Okay. So diversity means that ultimately the fading effect, that means it causes everything to go zero, that should be overcome, or destructive interference should be overcome. Yeah. So diversity reduces the probability of deep fading by increasing the chance of multiple components to reach the receiver. That is what is called diversity. So basic diversity, fundamental requirement of implementing diversity in wireless communication channel is it should have multiple branches. That means multiple communication channels. That means multiple signals being generated between the transmit and the receive section. Each of the signals should be independent of each other. That means each signal will have a different effect of fading. Okay. Each multipath component 1 and 2 will have different component of fading, and if one is being lost because of deep fading, the other component will reach the receiver. So the probability of the signal being lost due to destructive interference can be overcome. Okay. So if we take one numerical example, how diversity is helping you in understanding in overcoming the fading effect, let us take this example here. So let us suppose that the probability that one branch experiences deep fading. Deep fading means destructive interference or strong intersymbol interference. Let that probability for a single channel be P. Okay. Now suppose there are n independent channels. Why we need multiple channels in diversity? This is the concept that is being established here. So suppose there are n independent channels. Then the probability of each channel to experience deep fading is p to the power n. Okay. So if suppose probability is 0.1 for one channel. So if for n channel, that means n channel is 3 channels, suppose here. So p to the power n is nothing but 0.001. So you see here, if you compare the 0.1 and 0.001, you will understand that the probability that the signal will experience deep fading for multiple channel is this value is very, very small compared to 0.1. That means if I have one channel here, so one channel will experience more amount of fading compared to 3 channels. So multiple channels reduces the probability of fading effect. So this is the main concept here. Okay, so if you have multiple channels, the probability of experiencing fading reduces. Why? Because p to the power n factor. So n is the number of channels. As you increase the number of channels, the chance of losing signal due to fading, it reduces drastically. Okay, that is why diversity greatly reduces the probability of signal failure. So this example is one of the best examples to understand Why we need diversity technique? How diversity technique using n number of channels or multiple channels is able to handle fading effect or probability of signal failure or signal loss due to this fading effect can be reduced. Okay, so this is the best example to understand the requirement of fading in your signal communication. Okay, now comes the question of correlation and how the channels, the multiple components should be unrelated to each other. Okay, why they should be unrelated to each other, or what do you mean by relation and correlation and between the different kind of channels? Okay, so the most important factor of diversity is that there should be multiple channels or multiple copies of the same signal being transmitted from the transmit to the receive. Each of the channels should have low correlation, or they should be uncorrelated or independent copies of the same signal. So independent copies means every signal will experience different amount of fading. Okay. So they will experience independent amount of fading. Independent amount of fading means the effect of multi-path propagation will be different for each of the signal. Okay. And they will not be related, means they will not be similar. Now, what do you mean by correlation? Correlation is given by a factor which is called rho here. So what is the value of rho? Rho, if it is equal to 0, 0 means the value is very, very less or almost equal to 0. That means two signals are completely different from each other. So if you see here, the black signal and the red signal, the variation in the black signal is different compared to the variation in the red signal. Okay, that means the signal is completely different. Two signals are completely different means correlation is 0. That means they are independent of each other, completely independent of each other. Okay. Now, if you see here, the value of rho is increasing. It is increasing to 0.7. 0.7 means what? That means the value of correlation factor is increasing. Is increasing means the two signals are almost fluctuating with a similar fluctuation. They are experiencing almost similar fluctuation. That means they are no longer independent of each other. They have similar variation in some areas and they are dissimilar in some areas. So you see here in this area, the variation between the two signals is almost same, but in this part, the variation between the two signals is almost different. Now, as this factor is increasing, it is increasing means the value of this correlation factor is increasing and it is almost equal to 1. That means that both the signals are entirely equivalent or it is almost similar to each other. So you see that the amount of correlation is increasing in this direction. That means as the value of the correlation factor is increasing, the similarity between the fluctuation of the two signals is also increasing. Okay. So in diversity, what is the requirement? In diversity, the signal should be unrelated. So the requirement is this. That means the factor should be all equal to 0 or as low as possible. So this is not the requirement of diversity. This is not the requirement of diversity. Diversity requires this factor. Yeah, so diversity requires low correlation or uncorrelated signals. So we should have different amount of fading for each of the signals. So diversity needs this first scenario. Second scenario and third scenario is not a requirement of diversity, or if similar signals happen, then diversity cannot be used here to overcome fading effect. Now, what are the different types of diversity that is there in your syllabus? For diversity, there are 4 types actually. So category classification of diversity we can do in terms of time, we can do in terms of frequency, we can do in terms of space, and we can do in terms of polarization. Okay, all these are different factors of the same signal. So when we are saying it is having time diversity, that means the signals, multiple copies of the signals from the transmitter to the receiver can be transmitted in different time periods. So they are actually not being transmitted in the same time. They are actually being transmitted in different time instances. That means T1, T2, like this, different time instances. Different time instances means they are not being transmitted in the same time. They are transmitted in different time periods. Okay, so they are actually independent time durations is there for each signal transmission. Frequency diversity means what? Frequency diversity means that each of the signal that is being transmitted from the transmitter to the receiver, multiple copies that are being transmitted, they are modulated using different carrier signal. That means for one signal, the carrier signal is FC1. For another signal, the carrier signal is FC2. So like this, you will have multiple carrier signal being used for transmitting multiple copies of the signal from the transmitter to the receiver. Now, what is space diversity? Space diversity means I'm increasing the number of antennas in the transmit side and the receive side. So, multiple antennas are being used both at the transmitter as well as at the receiver side. So, how multiple antennas are going to help in overcoming diversity, increase diversity and overcoming fading, we will go through it in the next lecture. Okay. Then comes polarization diversity. Polarization means the orientation of the signal. Okay, so orientation of the signal means suppose I have electric. So when I'm having radio wave propagation means I have electric field and magnetic field being EM signals being transmitted. So suppose if the electric signal, so this is my electric field actually. So let's say that the electric field components of one signal is oriented vertically. So from the transmitter to the receiver, that signal that is being transmitted, one of the component, MC component or multipath component is actually having vertical signals or vertical electric field. Suppose another signal is being transmitted which is having horizontal orientation of the electric fields. So this is another signal that is one of another component, second component of the signal which is being transmitted from the transmitter to the receiver. So the first signal is actually called vertically polarized signal, and the second signal is called horizontally polarized signal. Why? Because of the orientation of the electric fields in the transmitted signal. The first component is called vertically polarized signal, and the second component is called horizontally polarized signal. So what is this polarization basically? Polarization means orientation of the electric field in the signal when it is being transmitted from the transmitter to the receiver. So same signal is being generated, multiple copies are being generated in the wireless communication channel. In one copy, it will have vertical alignment, in one copy, it will have horizontal alignment. So there are two completely different orientation. So there is no relationship between MC component 1 and MC component 2. So they are unrelated in terms of polarization or orientation of the signal electric field. Okay. So this is called polarization diversity. Next, we have something which is called time diversity. So now we have classified this broadly. So this is my first classification, this is second classification, this is my third classification, and this is my fourth classification. This is broader classification. Now we will go through it one by one. So what do you mean by time diversity basically? Time diversity means two signals will be transmitted in different time periods. So signal 1 will be transmitted in time period T1 and signal 2 will be transmitted in time period T2. The difference between the time period is called delta T. So independent time, independent signals are being transmitted from the transmitter to the receiver. Yeah. So there are n different time instances and n different signals are generated from the transmitter to the receiver. Yeah. So m different means these are all same copies of the same transmit signal. Now the separation between the transmitted signals, that separation is called delta T. Now if the most important factor is for this time diversity, this separation should be greater than the coherence time. That means the time period, minimum time over which the channel remains unchanged. That is called the coherence time, or it remains flat or fixed. Okay. So this separation should be greater than the coherence time. Yeah. So this ensures that why this is needed, this condition is needed to experience fading effect in the transmission through the wireless communication channel. If the reverse is there, then there would be no fading or very small fading or negligible fading. But we want large fading or wide fading, okay, or deep fading. So this is one of the important factors for time diversity, that the signals can be transmitted into different time instances. The separation between the time instances, suppose this is T1 and this is T2. So the separation between T1 and T2, that is delta T, should be greater than the coherence time of the channel. Okay. Now, this will cause each of the copies to undergo independent fading. Independent fading means this will experience a different amount of fading or distortion. This will experience a different amount of fading or distortion. So, two components will be having different amount of fading, means they will be reaching the receiver and they will be uncorrelated to each other. There would be no similarity between signal 1 and signal 2 at the receive side. Okay. So, advantage is it is able to reduce fading effect by using diversity. How it is able to reduce fading, we will go through this in the upcoming lectures. But overall, it is used for reducing fading effect because we are able to generate multiple copies which are independent to each other from the same source. Okay. Disadvantage is it reduces data rate because same symbol is transmitted multiple times. Because same copy of the signal, transmit signal, is being transmitted in multiple time periods, so the data rate actually reduces. So it is actually deteriorating the performance of the channel or communication channel. Okay, so data rate is reducing means it becomes slow. A less amount of data can be transmitted. Next comes frequency diversity. Frequency diversity means I've already told you, same signal from the transmitter will be modulated using different carrier frequencies. So different carrier frequency means for the signal, first signal we will be using carrier frequency FC1, second signal we will be using FC2. And the frequency separation between the two carrier signals is called delta F. Condition is del F should be greater than the coherence bandwidth. Coherence bandwidth is the range frequencies over which the channel remains unchanged. Okay, so this condition is very, very important in order to enable different frequency components to experience independent fading effect. Yeah, in this frequency diversity, we are using only one antenna, but we are using different copies of carrier signal. So different copies of carrier signal means what? It means single antenna. So there is one antenna only. Single transmit antenna is generating multiple copies. That means power is actually split into different components. So suppose I'm generating three components. So three carrier frequencies. Three carrier frequencies means total power, that is my transmit power is PT, that is being split in P1, P2 and P3. So addition of all these three components will give you the total transmitted power. So what is the effect of frequency diversity? The total transmitted power is actually split up in multiple carriers. Okay. So multiple carriers means multiple frequencies would be there. So that is why if you see here in this graph, you find that all the frequency components or signals are independent of each other. You see none of them are having same variation with respect to the distance of the time. Find that each of the signal variation is independent of each other because they experience different amount of fading due to the channel and the multipath propagation. Okay. So frequency diversity is often used for microwave line of sight communications. So every component, carrier component carrier is different, means they are separated in frequencies also. So that delta value that is there, del F. So that del F value should be greater than your coherence bandwidth so that each signal will experience independent fading effect, or each frequency will experience independent fading effect. Okay. Next is called space diversity. Now, what is space diversity? Basically, space diversity means use of multiple antennas. Multiple antennas can be used both at the transmit section and the receive section. So, when you're using it in the receive section, it is called receiver space diversity. When you're using in the transmitter section, it is called transmitter space diversity. Okay. So, what is receiver space diversity? Receiver space diversity is nothing but you are using n different antennas in the receiver to obtain each of the independent fading signals. So you will have multiple antennas from 0 to M at the receiver side. Each of the multipath component MC1 to MCN, all these multipath components will be independently received by independent antennas at the receiver side. So independently received means there would not be any overlap between the two signals multipath component here. So the receiver job becomes much easier. Now it can handle the multipath component and extract the actual transmitted signal from each of the multipath component from each of the antennas that is receiving the signal. Now the techniques that are used for doing regenerating this transmit signal from this independent receive signal, that we will discuss in the next lecture. Okay. So you just remember what is the structural, what is the system diagram, block diagram of for space diversity. So this is for receiver space diversity, and for transmitter space diversity, we have different antennas in the transmit section. So I'm generating the same signal here. Using the same signal, I'm transmitting using the different antennas, multiple copies. Each of these copies is going through the channel. They will experience different amounts of fading. So the fading would be different for each of the channel, independent of each other. Why? Because different frequencies, different signals will experience different channel effect, and each of the signals will be unrelated, or they had no relation between them, and they will be received by a single antenna at the receiver side. So here multiple antennas in the transmit side, single antenna in the receiver side. Okay. So here power of the transmit power PT is actually split up into m number of signals. So they're splitting the power in the m antennas at the transmit side. Okay. Now, space diversity actually is implemented by keeping multiple antennas both at the transmit and the receive. You can keep multiple antennas and you can increase those diversity in terms of you will receive, you will generate separate signals, uncorrelated signals at the transmit side, or you will receive uncorrelated signal at the receiver side. So space diversity means you are increasing the number of channels, or you are increasing the number of independent copies of the same signal between the transmitter and the receiver signal, so that each of the component will experience different amount of fading and they will be received at the receiver side. So this is how it is in. Different types of space diversity are, in your syllabus you have all 4 categories. What are the 4 categories that you have? First category is called SISO, that means there is single transmitting antenna and single receiving antenna. So this is called single input, single output. Okay. Next is you have single transmitting antenna but multiple receive antenna. So this is called single input, multiple output. So this is the second criteria. Third one is you have multiple transmit antennas and you have a single receive. So this is called multiple input, single output. That's the third one. And finally, the fourth one is multiple transmitting antennas and multiple receivers. So you have multiple antennas both at the transmitter and both at the receiver. So this is called multiple input, multiple output scenario of space diversity. So this is the classification of space diversity in terms of number of antennas used at the transmitter and the receiver. So we have 4 categories here. Okay. So with this we come to an end of today's lecture. In today's lecture we have understood what is diversity, why diversity is needed, what are the criteria for implementing diversity in order to handle fading effect, and classification of diversity in terms of time, in terms of frequency, in terms of space, and in terms of polarization. We have done for studying the different types of diversity in your syllabus.